Friends, here there is a very important concept or theorem, whatever you say, that we need to know before going for the further problems based on prime numbers and odd numbers. Very, very important actually. If the sum of 3 or 5 or 7 or 9, basically odd numbers. If the sum of odd number of prime numbers, that means the number of prime numbers should be in an odd number, 3 prime numbers, 5 prime numbers, 7 prime numbers or 9 prime numbers, etc., is an even number. If that sum, the sum of odd number of prime numbers is an even number, then compulsorily one of that number must be, then one of that prime numbers must be 2, either one of that prime numbers must be 2 or all the prime numbers must be 2's. Okay, so I am not forcing you to believe this. Let us take some examples and prove this concept, right? I am taking 3 prime numbers, P1, P2, P3. Okay, so suppose all are odd concept. That means P1 is odd, P2 is also odd, P3 is also odd. Okay, P1 is odd, P2 is odd, P3 is also odd. Odd plus odd will give even, and even plus odd again will become odd. So this sum will not be equal to even. This sum will not, I am taking just 3 prime numbers and I am checking it. So this sum will not become even. So odd plus odd. So compulsorily one number must be 2, I am saying. So let us take one number as 2 and we will check it. So P1, P2, P3. One number I am taking as 2. This is 2. Okay, this one I am taking 2. That means this is an even number. 2 is the only prime, even prime, odd number and odd number. So odd plus odd will give even, and even plus even, obviously that will be even. Obviously that will be even. So or else that means compulsory 2 should be there. If you are adding up 3 prime numbers, 5 prime numbers, 7 prime numbers or 9 prime, that means odd number of prime numbers if you are adding, and if you are getting a sum of even number, compulsorily one of that number must be 2. And you also know the importance of 2. 2 is the only even prime number, 2 is the least prime, first prime, everything. Or else all the numbers must be 2. All the numbers must be 2. Okay, suppose P1, P2 plus P3. This is 2, this is 2, this is also 2. That means 6. 6 is an even number. So it cannot be like, sir, what if two numbers are 2's? So you said either one number must be 2 or every number must be 2. What if intermediate condition? It will not be satisfied. Suppose P1, P2, P3. I am taking 2 2's and some other is prime number which is nothing but an odd number. So even plus even. So even plus odd. Even plus odd. Even plus odd, again it will become odd. Again it will become odd. So it is not like that. Not either one of that prime number should be 2 or every number should be 2. Then only you can get an even sum. Okay. So now I think you this condition is wrong. So either you can have one of the prime number as 2 or every prime number as 2. Okay, so we proved it clearly here. So what is the condition? If the sum of 3 or 5 or 7 or 9, basically odd number of prime numbers is an even number, then one of the prime numbers must be 2 or all the prime numbers must be 2's. So let us use this concept in the problems that are coming. Dear friends, here comes the next question. If the sum of 3 prime numbers is 100 and one number is 36 more than the other number, in the 3 prime numbers, one number is 36 more than the other number, then one of the numbers is dash. Options are 17, 29, 43 and none. Friends, none option is also there. Generally people think that when none option is there, the right option, number of right options became less. But actually situation becomes more complicated when none option or none of the above not options are given, right? So we should be very careful here. So if the sum of 3 prime numbers, and we know the rule, when odd number of prime numbers, 3 prime numbers, 5 prime numbers, 7 prime numbers, 9 prime numbers, when odd number of prime numbers are added and the result is an even number. See, sum of 3 is an odd number and their sum is 100. That means 100 is an even number. 100 is an even number. 100 is an even number. Okay, 3 is an odd. So odd number of prime numbers is 100. That means even number is coming as sum. So now there are two options. We know the rule. So in this case, when the sum of odd number of prime numbers is an even number, so either one number must be 2 in that odd number of prime numbers, either one number must be 2, or all the prime numbers can be 2. These are the only two options that are given. So let us check some options, what is possible, what is not possible. My dear friends, I am taking 3 prime numbers. So he is telling the sum should be 100. And if I take all numbers as 2 plus 2 plus 2, yes, the sum is an even number, but it is not equal to 100. So it is not equal to 100 because he gave sum as 100. So the sum is not coming to be 6, it is coming to be 100 since it is given in the question. So all the prime numbers are 2, that option is gone. And second doubt you may get, sir, P1, P2, P3 is there, and he is telling that one number is 36 more than the other. That means if I take like this P2 and one number is P2 plus 36, this is the option, and sum is 100 obviously. In these two numbers, why can't this number be, wherever the relationship is given, why can't this number be 2? No, it is not possible, because if you take this number as 2, the next number will be 38. 2 and 38. And 38 is not a prime. 38 is not a prime. 38 is not a prime number. So this number also cannot be 2. This number also cannot be 2. So all the prime numbers cannot be 2 because of the sum. And wherever the relationship is given, in that number also one number cannot be 2. The only option is the third number can be 2. The only option is the third number can be 2, that's all. So let us take the other number, wherever the relationship is not given, the other number, the third number, will take it as 2, one number, and we will try to solve this question. Clearly it is given P1 plus P2 plus P3 is equal to 100. One number is 2, the other number I have taken 2, and obviously P2 plus 36, where the relationship is given, these two numbers, is equal to 100. So I am just adding up. So 2 plus 2P2 plus 36 is equal to 100. So 2P2 plus 38 is equal to 100. So 2P2 is equal to 100 minus 38, that is equal to 62. 2P2 is equal to 62, which gives P2 is equal to 62 by 2, that is equal to 31. P2 is equal to 31. P2 is equal to 31, and P3, if you are going for P3 is equal to 2 plus 36, 31 plus 36, 31 plus 36, P3 is equal to nothing but 67. P3 is equal to 67. Yes, clearly we can see 31 is a prime number, 67 is also a prime number, no doubt about that. 2 already we know this is a prime number. So all the three are prime numbers. 2 is a prime number, 31 is coming, second number is coming as 31. That is also prime number. So P3 is coming as 67. That is also prime number. So what are the three prime numbers? P1, P2, P3 if you take 2, 31, 67, and definitely 31 and 36 difference, 31 and 61 difference is 36. So and if you sum up these values, definitely you are getting 100 also. Verified, 100% verified. So what are the, one of that number is 31 or 67, anything. One of that number, 2 is also there, 2 can be there, 31 can be there, 2 is anyway there, 2, 31 and 67 are the numbers. Nothing is there in the options. We are getting the three numbers as 2, 31 and 67. Nothing is there in the options. At least if one number is there, I can guess one of the number is 2, one of the, 2 is already there. Actually we know one of the number must be 2, but first only it is not there. So we are searching for the other two numbers, neither 31 is there nor 67 is there. So we have no other way, none is the option for this question. None is the option for this question because the numbers are coming as 2, 31 and 67. So I hope you understood this question. Very interesting question. It is a previous question for a competitive exam. Friends, here comes the question. If A, B, C, D, E are 5 prime numbers, A, B, C, D are 5 prime numbers, where A less than B less than C less than D less than E, and that means A, B, C, D, E are going in the increasing order. A is the least prime number and E is the highest prime number in this series. We can take like that. and a plus b plus c plus d plus e is equal to 306. So whether it is an even number or odd number, we will see later. A plus the sum of the 5 prime numbers is 306. Then find the value of a cube plus 2a. Then find the value of a cube plus 2a. The options are 33, 135, 1153 and 12. Okay, fine. My dear friends, now here we know the rule that when odd number of prime numbers, 3 prime numbers, 5 prime numbers, 7 prime numbers, 9 prime numbers, etc. When odd number of prime numbers, we add them up and the sum is an even number. And the sum is a even number. So what are the rules that we have? Either every number should be 2, all the numbers should have the value 2, or one of that prime number will be 2. Okay. So clearly we know A, B, C, D are 5 prime numbers. Okay. And how many are there? 5 prime numbers. 5 is an odd number. Odd number of prime numbers. That is very correct. And their sum is 306. 306 means it is an even number. So all the conditions are satisfied. All the conditions are satisfied. Now the option is either all the numbers must be 2's. So it is not possible because if you take a plus b plus c plus d, all the numbers as 2, 2 plus 2 plus 2 plus 2 plus 2 will give 10. So 10 is not there. So 306 is there. So all the numbers must be 2. Option is anyway gone. By looking at the question only we can say. So now one of the numbers must be 2. One number will be 2. So what is that number? Friends, you know speciality. What is the speciality? 2 is the only even prime number. Only even prime number. It is the least or first prime number. Least prime number is 2 only. Least prime number is 2 only. And one more thing is, in this series 2 must be there. In that series all can be 2's, that is impossible here. So here there must be 2, and in the least place, here in this place, the value of a must be 2. There is no other way. So here it is telling, so this value must be 2, because 2 is the only least prime number and one number must be 2. So obviously 2 occupies the value of a. So that is why the question is also about a only, because here only we can place a. There is no other choice for us. So least number here it is telling t is 2 must be there, and it is the only least prime number, even prime number. Okay, now a cube plus 2a is telling, that means 2 cube is 8, that means 4. 8 plus 4 is equal to how much? 12. 8 plus 4 is equal to 12. So D is equal to 12. So option D is the correct answer for this question. If you know the rule, the sum of odd number of prime numbers is an even number. So one of the prime numbers must be 2, or all the prime numbers must be 2. That rule we should know, and we also should know, anyway, you all people know, that 2 is the only even prime number, and it is the first prime number, and it is the least prime number in the natural number family. Okay, so 12 is the answer for this question. Now friends, here there is an interesting question. X and y are integers. So x and y is telling they are integers, and if x square by y cube is an even integer, x square by y cube is an even integer. He already declared that x square by y cube is an even integer. Then which of the following must be an even integer? So the options are, 4 options are there. One of that option must be an even integer. He is asking which of this option could be an even number, even integer. Okay, so option A is x minus y, option B is y plus 1, option C is x square by y power 4, and option D is xy. Okay, so now my dear friends, I am taking this is a very simple concept. If a number needs to be an even integer, even, it should be in the form of 2n, and for odd integer it should be in the form of 2n plus or minus 1. 2n plus or minus 1, where n is a integer, right? Now my dear friends, clearly he is telling x square by y cube is an even integer. That means it should be in the form of 2n. It should be in the form of 2n. So now x square is equal to 2n into y cube. Like this I can write. Now my dear friends, because of these 2, you can see 2 is an even number, right? 2 is an even number. So because of this 2, whatever may be the status of the remaining entity, that will always become an even number, because even into even number also, even into odd also, anything even or odd, anything that is multiplied by even will always become an even number. So this complete entity will become an even number. Why? Because of this 2. because of this 2. My dear friends, if this is even, this whole entire unit is an even number, obviously x square also will become even because of equality. Now, if very simple, if x square is even, then x also should be even, because x square means x into x is equal to even. So that is possible only in the case of even number into even number only will become even number. So x will always be even number. X will always be an even number. Now coming to the point of y. Y is an even number or odd number, that we will check. My dear friends, y is an even number or odd number, we will check. Now clearly I can say y can be even number or odd number. It can be anything based on. It can be anything based on this equation. Y can be anything. Y can be odd number or y can be even number, because x square is anyway even number. Even number means even into odd also will become even number. Even number is equal to even also will become even number. So even is already 2. 2n we can take, or else 2n we can take. What is this? Odd number. What is this odd number? Suppose if you take, if y is equal to odd, y cube is also odd. Y cube is also odd. So obviously if you take here y cube as an odd number, then also you will get even number. If y is equal to even, y cube is also even. So then also you can place y cube in the place of even number. So y can be anything. Y can be odd number or even number. So because on the other side even number is there, when you get y cube as odd number, then also the result will be even number. So when you get y is equal to even number, then also you will get an even number in the LHS side, because of this 2n or 2, whatever you say, that is an even number. So finally, so x is always even in this expression, and y can be even or odd. It can be anything. It can be anything, right? So this is what. Now I can clearly see x into y is the only option that satisfies even integer, because x is always even. X is always even. So if y is even, then also you will get even number. If y is odd, then also you will get even number. Am I right? So clearly I can see that is the only option that satisfies always even concept. But still you want to check, sir, yes, I agree that xy is the correct answer, but prove that a, b, c are wrong also. Not only prove right, not only proving right, but also you have to prove x minus y, y plus 1 and c and option c are wrong. Okay. So xy is always correct. Now I will also prove that a, b, c are not always correct. That also will prove. Wrong also will prove, right? Now my dear friends, option 1 is x minus y. X is always even number, we know. X is always even number. Now in the place of y we will take even or odd, and we will check. We will check. Okay. So we will check. We will take y is equal to even number or odd number. I am taking some, x is always even. I am taking 8. 8 minus 4 is 4, that is even. Correct. But if you take 8 minus 3, that is an odd number, you are getting 5, which is not equal to. So option A is wrong. We are not always getting even number, even integer, right? Now that means option A is wrong. Now y plus 1, I am taking, if y is equal to even, if y is equal to even number, 6 plus 1, if y is equal to 7, 7 is not equal to odd. But if I take y is equal to odd number, 5 plus 1 like, then I am getting even number. Okay. Now also that means option B is not correct, because we are not getting always even integer. Now coming to the most important option, that is x square by y4. So first I am taking x and y both are as even numbers. Suppose I am taking 8 square by 2 power 4. Sum. X is a even number, y is also even number. That means 64 by 16, that is equal to 4. Yes, that is an even number. But if I take odd number here, like 10 square is in x is always even, like 3 power 4, odd number, y is equal to odd number, like 100 by 81, like we are getting some decimal answers. I don't know whether it is even or odd sometimes, but we are getting decimal answers. Decimals are not integers. Decimals are not clearly told, it should be an even integer. Sometimes it is not an even integer. Even if it is integer also, it is a decimal, so we will not consider it as an even integer. So option C is also wrong. So the only thing that we can prove, we not only proved what is right, x and y we proved right, we also proved option A, option B and option C by taking proper examples. I have proved A and B, C are wrong. Actually this will not take much time in the exam. By just looking at the options only we can tell, but for the sake of subject I told you how to prove some answers are wrong and when you are taking directly an answer as correct answer. So remaining also wrong weight, because MCQ questions, if it is MSQ questions, there can be multiple right answers. So if it is MCQ question, there will be one answer, right? Multiple select questions. Sometimes in exams, more than one answer will be correct. In that case, we also should prove what is right and what is wrong. So clarity should be there. That is why I proved option A, option B, option C are wrong. Option D is correct answer.